Everybody, my name is Rodney Trusty. I'm a hobbyist maker. I work in defense, but in my personal work, I do e-textiles, and I want to share with you guys some techniques that I use for designing e-textile circuits. And I'm going to use as an example one of the projects that I've been working on. It's a flex glove. You've probably seen these on the internet. People designing gloves that have flex sensors in each finger, and they move their hand around, and they use it for biometrics or for whatever their purposes are. So I figure that's a perfect example to use to take a look at some of the aspects of a textile circuit, compare that to what we're used to with normal circuits, so you can get an understanding of how you can create circuits using textiles. So I'll begin. If you take a look at this first slide, what you see is each element of a conductor thread label. And I'll go ahead to the next slide here. This is the CAD view. This is what that glove looks like in the CAD software. This is actually version 1 of the glove. Version 2 has been extended. So one of the first components of an e-textile circuit is the placement stitch. And what the placement stitch does, it provides a jig for you to position your solid PCB components. And the reason you need this is because without that, you don't know where to put your components. And the components have to be placed with accuracy. So it's important that the machine lays out a placement stitch so you know where to place your components. It also provides stabilization because as you're stitching, you're going to pull and snag your material, and that's going to move your components out of place. But if you place a placement stitch, it helps resolve this. Also, the visual outline helps you if at some point during the design process a component moves out of place, you have a high contrast thread underneath that you can see that something has gone wrong. Very important. The next aspect is it's the PCBs. Everybody's already familiar with these. So PCBs are going to provide all your control, sensing, and your logic to your e-textile circuit. You want to design these as small as you can, but there is a sort of a diminishing return if you push too hard with getting things small. So in these images, you see this is an LED matrix controller, and on the right side, you see that it's fixed to the substrate with conductive thread. And that conductive thread also provides electrical connection to each of the signals. The next element is the conductive stitches. So the conductive stitches are what create electrical paths between the components that you lay on the substrate. And this is done with conductive thread in your embroidery machine, and they come in all different flavors. I get asked often which one is the best. All of them are bad, so just go for any of them. They really are, all are difficult to work with. So this is another element. This is a via, which probably is better called a bridge. But in normal electronics, we use vias to go from one layer to the next. In textile electronics, you're going to use a bridge to jump traces over one another instead of going down to a different layer and crossing over that way. So via allow conductive paths to jump over one another without making contact, and this prevents unintended connections between crossing conductive threads. When you have LED matrices or complex circuits, these are invaluable. In this image, what you see is an LED matrix, and as the X and Y traces cross over one another, there's a little white bridge for the conductive trace to jump over and not make contact. So the next one is a splice pad. This is a conductive pad that serves as a bridge for extending circuits. Embroidery machines are very limited on their amount of space. So oftentimes if you want to have a shirt like the one I'm wearing and you want to have electronics all throughout, you'll have to stitch two pieces together. What you would do is you would embroider a little pad on the end, and that would allow you to continue your circuit onto another circuit. So it's useful when connecting multiple circuit layers or attaching additional components to an existing embroidered circuit. So yeah, if you're doing 2 layers, or if you're extending beyond your working area for your machine, you're going to have a splice pad to facilitate that connection. It's important that I didn't put here, one thing that you want to do is you want to use highly conductive thread in your splice pads, because that's where you're going to find a failure if you make a mistake. And you want to minimize the chances of a failure. With e-textiles, the difficulty comes in small errors that are really, really difficult to find. So it's very important that your manufacturing process minimizes errors, even if it takes longer or costs more. Attachments, these are additional materials added to the fabric during the manufacturing process. For example, an insulating layer or a connecting layer. So when you have another component or circuit that's going to attach to your circuit. That's an attachment. This is very common. In this image, what we have is an interposing layer that controls a pressure sensitive matrix. So those splice pads you see around the perimeter of this in this image are connected to the X and Y traces of a pressure sensing matrix. And then at the bottom, you see an attachment. That attachment connects to some generic JST pins that you can connect your microcontroller to. So attachments, any additional material that you have to attach to your circuit. Pretty straightforward there. Insulation. This is very important, especially if you're using readily available conductive threads that you'll get from Adafruit or any of those guys. Conductive traces may be insulated by covering them with a satin stitch of normal thread. All you're doing is stitching around the trace with normal thread. This protects the conductive thread from wear and electrical interference, and it improves the reliability of embroidered circuits. What I found is certain threads like Madeiras, they're coated with a polymer, or they may be coated with some sort of conductive material, and that conductive material rubs off as it passes through the machine and as you just move around through day-to-day life, especially if you put it in the washing machine or something like that. So it's really important to insulate all of your traces. Another thing you'll find is that thread likes to fray. If you pick up any shirt that you have that you've ever worn and you put a magnifying glass up it, you'll find frayed thread and frayed fabric. With a circuit, that's a very bad thing. You want to minimize the chance of that happening. So insulation keeps those frays from branching out and touching an adjacent trace. This is very important. But I also must mention insulation dramatically increases manufacturing time. Usually could double it. Decorative stitches, these are normal stitches. This is intended for visual appeal. They're not meant to be part of the circuit. So this is a design for North Carolina State, which is one of the only colleges in the U.S. that teaches e-textiles. And this has LEDs mixed in with a decorative stitches. So normal stitches mixed with circuit stitches. Okay, and this is near the end of the slideshow here. We have tie-in and tie-out stitches. This is very important. You don't have to worry about this when you're doing traditional electronics. If you design your circuit, you send it to the board house, and they're going to etch away anywhere you don't need copper. With an embroidered circuit, you have to worry about where the needle is going to go and the path that it's going to take throughout your entire circuit. So you can't design electronic embroidered circuits if you don't know embroidery. One of the things you have to do is you have to tie in and out before you run your trace. So in this example, we have two parallel traces. One of them has a tie in and tie out, and one of them doesn't. Now, the one on the right is the one that has a tie in and tie out. What that means is that you see those two lines leading into the trace. I did a lock stitch on one end and then jumped over into the trace, ran the trace, and then jumped out on that second exiting line. And we're going to see the effect that has on the next slide. So we're going to take a closer look here. And looking at the image, we're going to look at the image on the trace on the left, and we're going to follow the numbers. So here I am. I'm going to start at number 1 with my needle. I'm going to stitch up to number 2. I'm going to stitch down to number 3 and then back to number 4 where you see that red mark, and then that's it. On the right hand side, we're starting on number 1, which is outside of the trace. We're jumping into the trace with number 2, going up and down with number 3 and 4, going to number 5 where we started on the trace, and then jumping out of the trace again to number 6. That seems like extra work, but you'll see in the next slide why we have to do that. So starting a stitch directly in a line makes it prone to short circuits. To avoid this, the needle should first tie into the fabric away from the design, then jump into the design. When finished, it should jump out. This becomes a little bit more complicated when you have many traces, because you don't want, for example, another trace to come by and sew over your tie-in with tie-outs. But for this example, we just have 2 traces, and this is what happens. So you have a bird's nest due to uncontrolled stop and start, and this increases the chance of a short circuit. Our line on the left, we see, created a bird's nest because we started our sewing in the middle of the trace. With a normal embroidery, let's say you were going to get a patch done with your name on it, you don't have to worry about that. That's on the back side, nobody sees it, nobody cares about it. But if you had another trace directly adjacent to that one, that's a short circuit that could occur. And what would happen is you'd find that short circuit because it's very obvious. you trim it the best you can, and then there'd still be a tiny little thread that you did not see, and then you'll bang your head wondering why your circuit doesn't work. So always jump in, jump out. Don't take the chance. You won't find out until your circuit's already done and it's not working. And that's the last slide of that show. One thing I wanted to show here was the platform that I use here for designing these circuits. It's a custom software design called Digital Fiber Studio. And the reason I had to do this was because there was no software that treated the circuit as a circuit and an embroidery. Circuit traces have properties. They have, at least in the embroidery world as well, they have how many passes, how conductive it's going to be, what kind of thread you're going to use for that trace, where the tie-in, where the tie-outs are going to be. So it was necessary to create a software that included all the things that I was learning as I was going along. And that's what this circuit, this is here. This is a biometric glove, which I'm sure you've seen many times before, as we talked about in the beginning of the slideshow. And one of the things this software could do is it can simulate what the machine is going to have to do. Why would you want to simulate that before you run it? Because you want to know if you have your tie-ins. You want to know if you have two traces that are crossing over one another that shouldn't be. You want to know exactly how the needle is going to travel as it executes your design. When it comes to traditional electronics, you never have to worry about that. The board manufacturer is going to worry about that. With sewn circuits, it doesn't matter. So here's a quick simulation. I'm going to drag through the simulation. There's your placement stitches. It's going to place those placement stitches, move out of the way so I can put all the components down. And then it's going to start sewing the components in. That's your I2C it's sewing in. That's your ground that's going around the fingers, and so on and so forth. So that's pretty much a summary introduction into e-textile circuits. I do have a free ebook. If anybody reaches out to me, I don't know if I should share my email publicly, but admin@digitalfiber.us ought to work. AGMIN at digitalfiber.us. If you send me a message there, I'll send you the ebook for free. If you want to get involved with e-textiles and have a project, I'll share and help with you as much as important to the amount of time I have available. But yes, that's about it for this. Right?